the mean of the sampling distribution is equal to mu is equal to 40.125 millimeters. And the standard deviation of a sampling distribution is equal to the standard deviation of a single unit divided by the square root of n is equal to 0.002 divided by the square root of 4, which is 0.001. This does not depend on the shape of the distribution, so you don't have to have a normal curve just to have a mean and a standard deviation here. Since the standard deviation of the sampling distribution is equal to the standard deviation of a single unit divided by the square root of n, which is the number of units in your sample, you simply put the numbers 0.005 and 0.002 into your equation and solve for n like you did in algebra. Divide that, square it, you get 16. The mean of the sampling distribution of number of strikes is equal to mu, the mean of the population, which is 6 strikes per kilometer squared. The standard deviation of the sampling distribution of x bar is equal to the standard deviation of a single unit divided by the square root of n, the number in the sample. 2.4 divided by square root of 10 equals 0.7589 strikes per kilometer squared. The reason why we can't calculate the probability that the mean lightning strikes is less than 5 based on a sample of 10 is because we do not know what the population distribution looks like. If we had a larger sample size, we could actually do the problem, but not with the sample size of 10. With the sample size of 50, which is larger than 30 obviously, the central limit theorem tells us that it's safe to use a normal approximation. With the standard deviation of the sampling distribution of 2.4 divided by the square root of 50 equals 0.3394 strikes per kilometer squared. So to find the probability that the sample mean is less than 5, you simply plug into the equation probability that z is less than 5 minus 6 divided by the standard deviation of 0.3994, which is a probability that z is less than negative 2.93, which is 0.0016, shown here on the graph.